Welcome, everyone. For today's prep, we're going back to integration techniques. And our first one is how to integrate trigonometric integrals. So we're going to be looking at, in this case, integrating odd powers of sine and cosine. How are we going to do this? So the type of integrals we're going to be looking at are going to have this kind of look, where we have maybe a power of sine, maybe a power of cosine, and at least one of these exponents is an odd integer. All right, so our strategy for how to do this is first we have to identify which of our trig terms has the odd power. And whichever one has the odd power, we're going to take one of them and we're going to factor off one of those trig pieces and put it next to our dx. That's going to be our first step. And from there, the rest of it is going to rely on this trig integral, or this trig identity. This is going to be our main trig identity that we're going to use. Sine squared of some angle plus cosine squared of some angle is equal to 1. And it's worth mentioning, just a quick note here, when we write sine squared of something like x, sine squared x, what we really mean is we're taking the sine x function, the sine function, and we're squaring the whole thing. So, it's important to kind of remember that for these different powers of sine and cosine. So when we see something like sine squared of x, what we really mean is we have two copies of sine x that we're multiplying together. All right, so we're going to come back and revisit this strategy, but let's kind of go through it by doing an example. So we're going to look at example 1. All right, so we're going to integrate, for this example, we're integrating cosine of x cubed. So the first step is, well, we see that cosine has the odd power. So we're just going to break off. There's 3 copies of cosine here. We're going to break off one of them. And we're going to move it right next to the dx. All right, so that's our first step. Identify whichever trig function has the odd power, and we're going to break off one of those and move it right next to the dx. So right now there's 3 copies of cosine. We're taking one of them and moving it right next to the dx. And then we have a cosine squared that's kind of left over here. So that's step 1 when we do this. Step 2 is all this other stuff, this cosine squared here, we want to convert into sine. We want to convert into the opposite trig function. So based on that trig identity, sine squared plus cosine squared, it's almost like we're going to want to think of sine and cosine as opposite functions. So they're based on that trig identity, we want to think of them almost as like they're counterparts to each other. So when we actually get it factored like this, we're going to save the cosine x dx. We're going to save that for our u substitution, which is going to come up. But all the other things here, we want to convert to our opposite trig function. So we want to convert these, in this case, to sine. And the way we're going to do that is with that trig identity. So we're going to, in this case, cosine squared x is going to be 1 minus sine squared x. So we're going to fill that in. So 1 minus sine squared x times cosine x dx. So all we did is we took that cosine squared and we're converting it now into an expression with just sine terms. And again, we're still saving this cosine x dx. So now the next step is we're going to start a u substitution. So our substitution rule is going to be handy here. And our choice for u is going to be the opposite trig function. So our choice for u is going to be sine in this case. And so when if we're doing a u sub, if we let u equal sine, do the derivative of sine, we get cosine x, and then we multiply by dx for our differential. And now we start to plug in the pieces. So we finish our u substitution just like regular. So the integral here is going to become 1 minus u squared, because we're saying u is equal to sine. And then this cosine x dx, we were saving that, and now we get to use it. That becomes our new differential du. And then if we finish the integration, the antiderivative of 1 is u. The antiderivative of the minus u squared is negative 1/3 u cubed. We throw on our plus c because we're doing an indefinite integral. And then finally, we convert back to x. So we get sine x minus 1/3 sine of x cubed plus c. And there's our answer. So the last step here is just to finish all the integration. So do the u integral. All right, and this is the process. So the kind of the steps here is we look at our trig function and we identify which trig term has the odd power. So in this case, it was cosine. So we peeled off, we factored off one copy of cosine, put it next to our dx, and then all these other remaining terms, the next step, step 2, was to convert all of these into the opposite trig function. So we went from cosine squared to 1 minus sine squared. And then for step 3, we start a u substitution. So we want u equal to the opposite trig function. So in our case, the opposite trig function was sine x. So we let u equal that opposite trig function, and the reason why it's going to work is because we were saving that for our differential. So let's try one more. Let's try example 2. Let's do the integral of sine x cosine x. So for this one, we have, again, it's a trig integral where we have powers of sine and cosine. Now both of these, there's like a hidden exponent of 1. So both of these are odd. So we could do this either way. So again, it's already there. So let's kind of reserve this cosine x. We'll kind of save that for later. So when we look at this, the cosine x dx, we're kind of peeling off. Well, there is only one copy, so we're just kind of peeling it off and putting it right next to the differential dx where it is. And so all the other terms in our integral, we just need to make sure that they're all the opposite trig function. So we get one copy of cosine x. And for step 2, we just want to make sure all of these to sine x, which they already are. So we break off the one copy of cosine that we have, we move it next to our differential, and then everything else in our integral has to get in terms of just sine x, which it already is. So we don't even have to use our trig identity in this case. So the next step for this is to do the u substitution. So our u substitution is we're going to let u equal sine x. So whatever term we put next to our differential, we're going to let u equal the opposite one. So we put cosine x next to it, so we're going to let u equal the sine x. And then we calculate our differential. So derivative of sine is cosine. And then we just kind of fill in the pieces for our u substitution. So this becomes the integral of u, because this sine becomes u. And then the cosine x dx, that becomes du. And then our antiderivative of u is 1/2 u squared plus c. And then we convert back to x. So we end up with 1/2 sine squared x plus c. And that's our antiderivative. So what we're going to try in class, we'll look at example 3 in class. But the kind of to spoil it a little bit, maybe get you thinking about it, when we look at this, we have powers of sine and cosine now, and only the odd power of sine here, or only the power of sine here is odd. So we're going to start this by, well, we have 5 copies of sine. We're going to take one of them and move it next to our differential. So that's going to leave us with sine raised to the power 4 times cosine squared of x times sine of x dx. So we had 5 copies of sine. I'm taking one of them, and I'm putting it next to the dx. And we're saving that. So we save that. And then all this other stuff, all these other terms, we're going to have to convert into cosine. So whatever trig function I'm kind of saving next to my differential, so in this case sine, everything else, all the other stuff has to get converted to the opposite trig function. So everything here has to get converted into cosine x. And maybe before class time, think about, so the cosine squared here is good. Think about what we might do with this sine to the power 4, sine of x raised to the power 4. We want to use that trig identity, sine squared plus cosine squared equal to 1. Think about what we might do here. And we'll see you in class. Bye-bye.